left off here on Wednesday.
Can I just turn that?
Yes. We had gotten through part A. We had discussed how that was not a function, or sorry, was a function, my apologies. Part A is a function. Part B. Is part B a function or not? How do I know? What kind of a shape is that in part B?
A few people actually.
That is a circle. Where's the center of this circle? 0, 0. This is a circle with center 0, 0. And radius what? Square root of 15. So that's going to be just a tiny bit smaller than a radius of what? 4. Because if that was a 16 at the end, our radius would be 4, right? 15 is just a little bit smaller than that, so it's not going to come out to be a perfect whole integer, but I know it's going to be a little bit less than 4. So if I were to just sketch this out, definitely not a perfect circle here. Is that a function?
Yeah. Wait, no.
Why or why not?
Circle function.
Do you guys remember what we said back here, why it was definitely a function?
Because x only equals to a specific y.
Yes. Remember, to be a function, every input is assigned to one and only one output. When I'm looking at a graph and I'm trying to determine whether or not that graph is a function, I can go to somewhere on the x-axis, like say right here. I'm going to follow that up. This would be a point, xy. Down here, I'm going to have the exact same x, but I have a different y. Same x value, 2 different y values. If I was to see that on the table, it would have a repeated input with 2 different outputs. Function or not a function? Not a function. When you're looking at things graphically, what I just demonstrated here, this is the vertical line test. This is how and why the vertical line test is working. We scan left to right with a vertical line so that we're going across our inputs, across our x's, and we're trying to see how many outputs there are for any given x value. So if it crosses in more than one spot, I know there's separate outputs for the same input value. What about part C? Is that a function or not a function? Not a function. Why?
It's just random.
It's not just random. That's not what makes it not a function.
Too many x's.
Yes.
For every one y.
Same reason as part B. If I draw a vertical line, I have 1, 2, 3, at least 4 outputs with where I chose to put this vertical line. So this one would not be a function. What about if I had something like that, or even more extreme? Would that be a function or not a function? That one would be a function. So it's not a matter that it's a random squiggle that means that it's not a function.
It's that it's going up and down.
Yes, it's specifically that it's like crossing back and forth against itself if you look at it in, a vertical fashion. All right. I want to do some evaluating. What are they asking me to do here on part A? What does that mean?
Negative 2 is part of the function.
Insert -2 for x.
Yes, we're going to insert -2 in the place of x. And then we're going to simplify as much as possible from there. So up in my numerator, I'm going to have -2. Down in my denominator, I have -2 minus 5. How would my denominator simplify then? -7. Can I simplify that fraction any further? The negatives are going to cancel. So when I evaluate this for f of -2, I get 2/7. Something I want to point out here just so that it's really, really clear in our minds. This value right here is going in for x. My output value, therefore, would mean what if I was graphing this? This is my y. This is why function notation can be replaced with a y. My function notation is equal to my output. Y represents my output. Part B, we're going to take what number and sub it in? Sub 0 in the place of x. Is that going to cause any problems?
Yeah.
Let's look. I put a 0 in my numerator for x. Down in the denominator, it becomes 0 minus 5.
Yeah, that wouldn't work.
Why?
Because you can't divide anything by 0. Well, dividing it by -5.
Yeah. I'm not dividing it by 0. I'm dividing it by -5. Is that problematic? No. It's if I divide by 0. I can't have 0 on the bottom. This whole thing is just going to simplify to be 0. So f of 0 equals 0. What about part C? This one is an issue. Why? Yes, I'm going to have a 5 in my numerator. That's not a problem. Down on the bottom, I have 5 minus 5. So I end up with 5 over 0, which is undefined. So f of 5 is undefined. What does that mean about the graph then? It does not touch that point. Since this is a rational function, specifically, it would mean that there is a hole at that point. Let's try another one similar to this. We're going to sub in some things. New function. Here's my new function rule. X squared plus 4x minus 5. First thing I want to put in for x is what? -2. So f of -2 is equal to negative, and then I make my substitution. -2 squared plus 4, and then another substitution with a -2 minus 5. Order of operations me. What do we do first? Exponent. So this is going to be negative what?
4.
-4. Then I come over here. I have 4 times -2, which gives me -8. And then I bring down that -5 at the end. So f of -2 evaluates to what? -17. Let's put in something different. Why don't we put in 2x in the place of x? So for f of 2x, I'm taking this whole expression now, so that'd be negative, and then I have 2x quantity squared plus 4 times the expression 2x minus 5. Same thing I did before. It seems a little weird to say I'm going to put something with an x in it in the place of x, but that's exactly what we're going to do. And then I want to evaluate each of these terms and combine anything together if I can. What happens when I do 2x and then I square that entire thing? 4x squared. So I have negative 4x squared plus what? Plus 8x minus 5. Can I simplify or combine anything there? Nope. That is my final answer then. F of 2x is equal to negative 4x squared plus 8x minus 5. What are we putting in the place of x in this last one? X plus 4. So f of x plus 4 is equal to negative, and then I do x plus 4 whole quantity squared plus 4 times x plus 4 and then at the very end, minus 5. What do I need to do first here?
Distribute the x.
Yeah.
Square root the x plus 4.
I have to square this binomial right here. So I have negative, and I'm going to keep this inside parentheses because I'll have to distribute a negative to everything, but I've got to follow order of operations first. Order of operations says exponents comes before multiplication. So I'm going to take care of this exponent first. What do I get when I do x plus 4 quantity squared?
Square plus 8x plus 16.
Yes. X squared plus 8x plus 16 plus 4 times x plus 4. I didn't distribute that yet, but I will here in just a moment. Minus 5 on the very end. I'm going to distribute the negative to each piece, and I'm going to distribute the 4 to each piece. So I have negative x squared minus 8x minus 16 plus 4x plus 16 minus 5. Can we clean anything up there?
You combine the x's and the constants.
We can combine the x's and we can combine our constants together. Negative 16 and positive 16, those are going to cancel out, so the only constant then I would have is this negative 5 at the end. So f of x plus 4 is equal to negative x squared. What happens when I combine my x's? Negative 4x, so minus 4x minus 5. We just composed functions together. We took an expression, x plus 4, we put it in the place of the x in another function, and then we evaluated that and we came up with a whole new, brand new third function. Interesting to note, what's the only difference between the original function and what we got after composing?
The negative 4x.
Negative 4x. It was a positive 4x, now it's a negative 4x. That's the only thing in effect that changed here. Right. I want to do quite a bit more substitution here. I'm going to give us a function rule, and I've got 6 different things that we're going to substitute in. Each one builds on the other. So we've got our function rule up here. First thing they want me to put in the place of x. A. So So when I substitute a in the place of x, I get 5a minus 2. Can I simplify that more than that already is? No, that's it. All we're doing is replacing the x with the a at this point. What about on part B? What are we subbing in? Negative a goes in the place of the x. So that's equal to 5 times negative a minus 2. Is this my final answer? Is that fully simplified? No, I would need to change that to be what? Negative 5a minus 2. Part C is not asking me to do the same thing as Part B. It has all the same symbols, all the same letters, but they're not in the same order, and so it's actually asking me to do something different. What am I supposed to do on Part C this time? Yeah, I'm going to multiply my function by a negative. So I have negative f of a, so I'm putting a in the place of x, but then I'm also multiplying the entire thing by a negative. So negative 5a minus 2. And then I'm going to distribute my negative sign here. So negative f of a is equal to negative 5a plus 2. What am I putting in the place of x in part D? A plus h. So f of a plus h is equal to 5 times a plus h minus 2. What do we do next? Distribute. I'm going to distribute the 5 to each of these pieces. So I get 5a plus 5h minus 2. Part E, all the same letters and symbols that were in Part D, but it is not asking me to do the same thing. What is this one asking me to do? Yes. F of A, we did that in Part A here, right? That was 5a minus 2. We're going to add that to f of h. So over here for f of h, I'm just going to put h and put it in the place of the x. So 5h minus 2. And then we're going to simplify this. What can I actually combine together? Negative 2 and negative 2. So I get 5a plus 5h minus 4. Different output, because it was not asking me to do the same thing as the previous problem. Part F looks kind of intimidating. It also looks kind of similar to things that we've done before. Do you guys remember seeing anything that looks like this with an H on the bottom?
Yeah,
Yeah.
by H.
We're dividing by H. We've got some stuff up on the top that we need to evaluate first. This very first piece, F of A plus H, we've done that already. That was our part D. So I'm going to write down what we got from doing that. That was 5A plus 5H minus 2. I'm going to subtract. Anytime I've got a piece after subtraction where I'm making a substitution, I am always putting this inside parentheses. Because I need to make sure, if necessary, that I remember to distribute that subtraction sign. Have we done f of a already?
We've done negative f.
We've done negative f of a, so I could substitute this in for this whole thing. Or I could go back to that one and distribute my subtraction sign. It's going to be exactly the same either way. So 5a minus 2 all over h. I'm going to need to remember to distribute mine. 5a plus 5h minus 2 minus 5a plus 2 all over h. Does this simplify at all? Can I clean that up?
The 5A's cancel.
5a's cancel. Does anything else cancel? The 2's. So what do I have left then? I have 5h over h. Close. It's just going to be 5. My h's cancel because the 5 and the h are being multiplied here, and division can cancel through multiplication. It can't cancel through addition or subtraction, but it can cancel through multiplication. So I get a 5 here. That whole big horrible looking fraction was equivalent to 5.
Why?
Why? Because calculus. I'm supposed to be preparing you for calculus, and this kind of thing that looks really horrible can show up after you've used what you learned in calculus, and it's actually not that hard to come up with. But then what do you do with it? How do you simplify it from there? That's what we're working on here, because those are algebra skills, not calculus skills. Those are old things. I want to do another one like this. Same 6 pieces, but with a new function rule. Here's my new function rule. We're going to do x squared plus 3 this time. For the first one, when I put a in the place of x, how does this simplify? A squared plus 3. Can't do any more to it than that. That is my final answer. For part B, we're going to put negative a in the place of x. So I would have negative a squared plus 3. I know that's going to simplify. How will that clean up? Just a squared plus 3. When I take something and square it, it will always become a positive. Anything multiplied by itself is a positive number as long as I'm working with real numbers, which they did say these are real numbers. What are we doing differently in part C? Yes, we're multiplying the entire function by negative 1. So negative f of a is equal to negative, and then I would have a squared plus 3. Distribute my negative. And negative f of a equals what? Negative a squared minus 3.
Can't you simplify the a squared?
We cannot. Over here, we could simplify because I was subbing negative a in the place of the x and then we were squaring it. With this function over here, I have the a squared and then we're multiplying it by a negative. That is a fantastic clarifying question. Thank you for asking that. So this one cannot be simplified further because here the a is being squared and then it's being turned into a negative. Part D, what are we doing?
2 plus h.
Substituting a plus h in the place of the x.
Means we have to use
Yep. So I have a plus h quantity squared plus 3. So I've got a binomial that I have to square here. What do I get when I square that binomial?
A squared plus 2ah plus x.
You guys are making me so happy right now. A squared plus 2ah plus h squared, and then throw that plus 3 on the end that comes down. Can I simplify more than that?
No.
Nope. We are done. Difference between this one in part D and what they're asking me to do in part E. They're separated. So part E, I have 2 separate functions that I am going to add together. One of them looks like this, and the other one looks like this, but with an h in it. So I would have a squared plus 3 plus h squared plus 3. And then I combine any like terms together.
that'd be a squared plus h squared plus 6.
Yes, a squared plus h squared plus 6. Different output, not the same meaning as when I put a plus h in the place of the x. One of the things I hope you guys are taking away from what we've done on the last problem and then on this one is that just having the same symbols does not mean we're going to have the same output. The order of those symbols, where they're arranged on there, makes a big difference in what our output is. Part F. We're going to take what we did back in part D, this guy right here. So a squared plus 2ah plus h squared plus 3. And I'm going to subtract what?
A squared plus 3.
A squared plus 3. Again, you could have substituted in what we did in part C where it was already distributed. All over h. Distribute my negative here. So I have minus a squared minus 3 all over h. This is looking an awful lot like that test problem that we had. Like ridiculously so at this point. What can I simplify from here?
That 3 and the
Yep.
negative 3 cancel the a squared.
A squareds cancel, positive 3 and negative 3 cancel. Let's write down what we've got left over then. I have 2ah plus h squared over h. Yes, ma'am.
I have a question. So since h squared is like h times h,
Mhm.
if you broke it down like that, could you cancel out like an h and then that h and then you get back like 2ah plus h? You know what I'm trying to say?
I do. I'm going to write down what you just said. 2ah plus h times h
Yeah, and then you would cancel out
over h. Can I do that? No.
why?
Because of this right here. These 2 terms are being added, and we have to distribute with division the exact same way we distribute with multiplication. So if you're going to cancel it over here, the only way that works is if it can cancel with something over here. So another way that you could look at this that would be mathematically correct is 2ah over my denominator plus h times h over that denominator. That would be a mathematically accurate way of looking at it, because we have to distribute our denominator to every single term in the numerator. Could I simplify something like this?
Yeah.
Can I cancel an h here?
Yeah.
Can I cancel an h here?
Yeah.
Yeah. Both of these have h in them, so I can factor an h out of both pieces. I can reverse distribute there. If I pull the h out of those two terms, I would be left with 2a plus h over h. Now I can cancel. This h on the outside is being multiplied to my factor. There are no addition or subtraction signs with that h out there. I can cancel that with my denominator. So 2a plus h is how this would fully simplify. That was a fantastic discussion about that piece. Let's look at one more that's like this. Not as many pieces this time, but I definitely want to be focusing on how the different placement of our symbols affects what our output is. So here's the function that we're going to substitute into. Its name is function g. What are we putting in the place of x for part A? 1 over a. So I have 4, and then grab my parentheses, 1 over a whole fraction squared. How is this fraction going to square? What will it look like when I'm done squaring it? 1 over a squared. Can I do anything more with this expression? Can I simplify it further?
Yeah.
Yes. How could I write it?
1 over 4 over 1, and then you have this times it, so it'd be 4 over a squared.
Yes. G of 1 over a is equal to 4 over a squared.
What's the difference? Cubes. It'd be 2 over a.
2 times 2 over a times a. We can't square root it, though, because I don't have it actually equal to something. It's just equal to my function notation. Yeah. What is the fundamental difference between what they asked me to do in part A and what they're asking me to do now in part B?
Dividing part A.
Close.
It's all
1 over the function.
1 over my function. So this one is going to be 1 over, and then the function, but where I've substituted what in? Yes, 4a squared. Can I simplify it more than that? You can't simplify that to 2a. That would be like saying 1 over 4 is equal to 1 over 2, and that is not true. All we can do is simplify or evaluate. We can't solve anything because we only have function notation on the other side. For g, what am I doing?
square root of a.
Putting the square root of a in the place of the x. So g of radical a is equal to 4 times radical a squared. Can I simplify that further? Yes. Because I have the squared on the outside and the only thing inside those parentheses, everything there is under the radical. My squared and square root are going to cancel. And so I have g radical a is equal to 4a. Why is that different from what they're asking me to do in part D? Yeah, they want the radical around the entire function here. So square root of 4a squared. I put a in the place of the x, and then we have a radical around the whole thing. Can I simplify that radical at all? Yes, I can.
2a.
That would be 2a. These two things are being multiplied together. Pieces that are being multiplied together underneath the radical can be separated. If I was adding or subtracting under there, I could not. Multiplying or dividing, I can. So square root of g of a is equal to 2a. Last little bit of time together is going to be spent looking at some graphs. You're probably going to want to snap a picture of these graphs so that you don't have to actually sketch the whole thing into your notes. Here's the first one. So I said take a picture. I thought about it after the fact. I should have printed these off, and I apologize for not doing that. All right, so domain. Which way am I scanning for domain? Left and right or up and down? Left and right. I'm going to start on the left. I'm going to figure out how far I can go to the right. If I have to pick up my pencil and jump forward, then I would need a union. What is the farthest to the left? This graph starts. -3, so right here.
But we don't know if the defect going on.
So -3, square bracket for that because it has a filled in dot. It's not an open circle here. Do I have to pick up my pencil before I get to the end? Nope. How far to the right do I go? 4. Square bracket or parenthesis? Square bracket. There's my domain. Range for part B. Now I'm looking which way? Up and down. I start at the bottom. What is the lowest or the smallest y value on this function? -2. Up to a maximum of what? +2. This is the highest it ever goes here. All the rest of the function is below that point. Part C is asking for something very, very different. You had a question, Anthony?
If the highest point, if it was 1/2 plus 3, would it be the max range or would it still go to the farthest right range?
I'm sorry, one more time.
If one of the points was higher than the one at the end, would that be the highest point on the range?
Yes. Like if you're saying if this bump actually went up here,
Yeah.
yes, then that would be the highest point. It's not always the farthest to the right. It is the highest on the graph.
Okay.
Yes. Good question.
Just in this example,
In this example, the highest point also happens to be the farthest to the right. But we are always looking for the highest on our range. Part C looks like what we were just doing a couple minutes ago, right? Function notation, and then they put a 1 in there. What is it asking me to look for? Because it gave me a graph, not a function rule.
what is 1 on the graph?
Yeah. So look at where x equals 1 on the graph. We want the output.
0.
We want the y value. So f of 1 on my graph, well, here's 1 on the x-axis. What's the output for that? 0. So f of 1 equals 0. Part D. What are they asking for there? all x such that f of x equals 1. Well, right here we said f of 1 equals 0. Where did that 0 come from? That was the y value. So I want all x's that have y equals what? Y equals 1. That's the part after the equal sign here. How many points do we have where the y is 1? 3. I've got one right here. We've got one right here. And one right here. So what are those x values? -1, 1/2, and 2. We use these curly brackets because it doesn't include the values in between. It's just a list, and it's only those 3 values. Last piece. I want all x such that what? Yes. All x's with y greater than 1. So here's where y is exactly equal to 1. So I'm looking at which pieces here then? Yep. I'm looking right here because that's above. And I'm also looking right here because that's above.
But we're using union.
We are going to need a union. Do I need parentheses or square brackets here? Parentheses, why?
Because it can't be equal to 1.
It can't be equal to 1. It's strictly greater than 1. But these are still my boundaries. So from -1 to 1/2, union, where else is it above that line?
Maybe it will too.
At 2 till 4. Would I use a bracket or a parenthesis with the 4? Every other number I've pulled right off of this line. Bracket, why? Its output is greater than 1. Its output is 2. That satisfies greater than 1. Not or equal to, it is strictly greater than. Does that make sense? Okay. We're going to stop right here. We still have some stuff to finish up in 3-4. We'll finish that on Monday. Your 3-4 homework is also going to be due Monday evening. So please start it over the weekend, but if there are pieces that you don't know how to do, hold off until Monday. After we've talked about things on Monday, if you still have questions, I'm more than happy to answer those.